Okay, so you asked about a problem where the two blocks are on the ramp and we've got friction. The interesting thing about this problem is that the block on the ramp is actually sliding down. So I've written some information that's given in the problem and we're asked to find the mass of the hanging block. So always the first job is to draw your free body diagram, the forces acting on each object. Normal force always acts perpendicular. Tension along the rope. The weight straight down, the weight straight down, which will break into components. Parallel, well, I can't get rid of that, sorry. Parallel along the ramp and then perpendicular. So my WX and my WY. Since the block's moving down the ramp this way, the force of friction is going to go this way. The forces acting on this one are much simpler. We've got the tension going up the string, same tension because it's the same piece of string. And then we have this mystery weight, or M2 times G. So after we've drawn our picture, our free body diagrams, we're going to do the sum of the forces equals MA, so apply Newton's second law to both blocks. So the block that's hanging is probably the simpler one to start with. If we write the sum of the forces in the Y equals MAY, then I'm going to write T minus M2G equals, now normally I'd have to put like negative MA to show that it's rising, but it's supposed to be rising at a constant velocity. So constant velocity is a zero acceleration and mass times zero is zero, which means the tension is equal to M2G. For the other block, we need both the X and the Y direction. So we start off with the sum of the forces in the X equals MAX. And if I choose down the slide to be positive, I'm going to get WX minus T minus F sub K equals 0. In the Y direction, I'm simply going to have N minus W sub Y equals 0, or N equals W sub Y. Now in this case, if this angle down here is 30 degrees, then so is this. So WY is your adjacent leg, which means it's going to go with cosine. So down here I'm going to write N equals mg cosine 30. Okay. Over here, I'm going to get rid of WX and I'm going to write mg sine 30 minus t. Instead of f sub k, I'm going to plug in negative mu sub k n equals 0. That's the substitution I always make for f sub k. Now I know the normal force from over here, so I'm going to make a substitution. Alright, I know everything in this equation except for t. So I'm going to end up with t equals 12 times 9.8 times the sine of 30. See if I can get that all written out. Minus just making sure I'm not making a sign error here. Add the t, so minus 0.23 times 12 times 9.8 times the cosine of 30. Okay, so when I get the tension here, I end up with a tension of 35.38 newtons. Once I have that 35.38 newtons, I can take that and plug it in back here. So 35.38 equals mass times 9.8. Solve for the mass, and I got 3.61 kilograms. Hope that helps.